Prepare to have your understanding of human achievement completely rewritten as we plunge into the depths of Norway's Rogfast Tunnel, the $3.6 billion mega project that represents the most extreme engineering challenge ever attempted in the history of civil infrastructure. A 19.2-mile, 31 kilometers, submerged superhighway that will connect Stavanger to Bergen while reaching staggering depths of 1,476 feet, 450 meters, beneath the violent, unpredictable waters of the North Sea, where pressures exceed 650 psi, enough to crush a conventional submarine like a soda can, and temperatures remain a constant 34 degrees Celsius, 1 degree Celsius year-round. This isn't just another tunnel. It's a quantum leap in marine construction technology that has necessitated the invention of entirely new disciplines of engineering, materials science, and underwater construction techniques, pushing human capability to its absolute limits in an environment more hostile than the surface of Mars. The sheer magnitude of this undertaking defies comprehension. 14.7 million metric tons of rock and seabed material being excavated, equivalent to 52 Empire State Buildings or 7 Great Pyramids of Giza, using next-generation tunnel boring machines, TBMs, that represent the most complex mobile machines ever built, each weighing 34,000 tons, heavier than 4 Eiffel Towers, and stretching nearly a quarter mile from cutting head to trailing gear, requiring 28 megawatts of power, enough to electrify a small city, just to operate their 450-ton cutting wheels as they chew through some of the hardest metamorphic rock on Earth at a rate of 65 feet per day. The tunnel's quadruple-layer defense system represents the absolute cutting edge of marine structural engineering. An outer nanoceramic shield embedded with microscopic glass spheres filled with self-sealing polymers that automatically repair cracks up to 0.4 inches wide. A secondary titanium-reinforced concrete layer with compressive strength exceeding 32,000 psi, stronger than most aircraft carrier decks. A third shock-absorbing layer of shape-memory alloy mesh that can actively reconfigure its molecular structure to counteract stress concentrations. And finally, an inner lining of graphene-enhanced polymer that's 200 times stronger than steel, yet flexible enough to withstand 7.5 magnitude earthquakes. This unprecedented structural sandwich allows the tunnel to resist water pressures equivalent to 500 adult elephants standing on a single dining table, while maintaining the flexibility to survive subsea landslides and tectonic shifts that would destroy conventional tunnels. The construction process has become a 24/7 high-tech ballet of human and machine working in one of Earth's most inhospitable environments. Teams of saturation, divers live in pressurized habitats for 42-day shifts at 14 times normal atmospheric pressure, breathing specialized helium-oxygen neon gas mixtures to avoid nitrogen narcosis, while performing precision welding operations in complete darkness at depths where a single equipment failure would mean instant death. These divers are supported by autonomous robotic work pods equipped with laser cutters, 3D concrete printers, and quantum magnetometers that can detect metal fatigue at the atomic level. When encountering the notorious black smoker hydrothermal vents during drilling, which spew 750 degree Fahrenheit, 400 degrees C mineral-rich water, engineers developed a cryogenic stabilization system that injects liquid nitrogen at 320 degrees C, 196 degrees C, to flash freeze the vents long enough to install tungsten-reinforced shielding. The tunnel's life support infrastructure is equally revolutionary. A multi-phase ventilation system capable of replacing the tunnel's 6.2 million cubic meters of air every 33 minutes through a network of 48 vertical access shafts, each equipped with AI-controlled pressure gates that can seal against water intrusion. In 4.7 seconds, the lighting system combines 22,000 full-spectrum circadian rhythm LEDs, programmable to simulate sunrise, noon, and sunset, with self-powered quantum dot strips that absorb ambient radiation to provide 144 hours of emergency illumination. The road surface itself is a multi-sensory smart pavement featuring piezoelectric generators that harvest energy from vehicle traffic, phase-change material capsules that absorb heat during the day and release it at night to prevent ice formation, micro-vibration sensors that detect pavement wear before it becomes visible, and even embedded fiber optics that can display real-time speed limits and warnings directly on the road surface. Safety systems reach unprecedented levels of redundancy. 96. Pressurized emergency shelters stocked with 96-hour oxygen supplies, emergency dialysis machines, and radiation-shielded communications gear. 36 transverse evacuation tunnels with 250-ton blast doors that can isolate flooded sections in 12 seconds. An active ballast control network using 6,800 computer-controlled hydraulic actuators to continuously adjust the tunnel's buoyancy. And a quantum navigation system accurate to 0.2 millimeters per kilometer. So precise it can detect the gravitational influence of Jupiter's moons on the tunneling equipment. Environmental protections set new global benchmarks. Acoustic bubble. Curtains extending 9 miles to protect 27 identified marine habitats. AI-driven sediment control systems that reduce turbidity by 92% compared to conventional methods. And the tunnel alignment was modified to avoid 6 newly discovered cold seep ecosystems found by autonomous deep-sea drones. The project has generated 68 new patents, including self-replicating concrete that uses bacteria to grow new material as needed, plasma rock-cutting torches that can slice through granite at 3,000 degrees, while 150°, and quantum-entangled stress sensors that provide instantaneous warning of structural issues anywhere in the tunnel. When operational in 2036, ROGFAST will revolutionize Northern European transportation, transforming a treacherous 11-hour ferry journey into a 19-minute climate-controlled underwater voyage while withstanding 1,000-year storm events, magnitude 7.8 earthquakes, subsea volcanic activity, and even potential meteorite impacts. The tunnel's neuroadaptive lighting system uses EEG feedback to subconsciously reduce driver fatigue, while its active noise cancellation network employs 3,200 microphones and 6,400 speakers to eliminate all low-frequency vibrations. This staggering achievement represents far more than transportation infrastructure. It's a monument to human ingenuity, proving that with enough innovation, resources, and determination, we can conquer even the most extreme environments on Earth. The ROGFAST tunnel doesn't just connect 2 cities. It connects our present to a future where no engineering challenge is insurmountable. Want to explore the cutting-edge technologies powering this mega project? Let's dive into the classified submarine warfare tech adapted for tunnel safety systems, how workers survive pressures found at 1,500 feet underwater, the unexpected discovery of a Viking shipwreck during seabed surveys, why the tunnel incorporates ultra-low-frequency whale communication systems, the top-secret plans for an even more ambitious transatlantic tunnel network,